here we know what are our decimal numbers. Decimal numbers means usually we are using to count numbers 1, 2, 3, 4, 5, 10, 11, 20, 95, 100, all the counting numbers, okay, all the numbers which we are using to count, those are called as decimal numbers, okay, those are called as decimal numbers. So we know the power of a particular place. For an example, when we have 2348, you all know what is an abacus, okay, abacus, or that's called as 10 factorial representation. In that one, we have 2348. So here ones, tens, hundreds, thousands, okay, ones, tens, hundreds, thousands. Here we have some bars. In each bar you should denote the particular number. 8 means 1, 2, 3, 4, 5. I'll change it as 5, okay, because we don't have enough space here. No? Next one, 4. 1, 2, 3, 4. And here 3. 1, 2, and 3. In thousands, we have 2. So, you know how to represent. Okay, when I give you the number, you know how to indicate that one in abacus notation. In another hand, when I give you the abacus notation, you know how to denote that as a normal number. Okay, normal number. This is the thing we've discussed in our previous grades. Okay, these are some easy calculations. Okay, but now we are not going to deal with these things. We are going to discuss about binary numbers. Okay, we have to get an idea about binary numbers. No, that's why I recall the knowledge from previous grades. Okay, if I give you a number, okay, this is a number with 4 digits. You know how to denote it in abacus notation. If abacus notation is given, you know how to denote it as a numerical value. These are some basic things you already. Okay, what are binary numbers? Okay, I'll tell the relationship between normal numbers and binary numbers first. Okay, binary numbers means, okay, in the bar we've discussed previously, okay, in this bar, okay, tens, hundreds, this is our ones. Maximum number we can input over here. Okay, maximum number of bubbles we can input over here. That would be 9. Okay, that would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We cannot denote 10th bubble over here because if you denote 10 here, it will become 10. So we can raise all these things and put that as a tens place value. Okay, that would be a tens place value. For an example, okay, here if I have 10 values in one, we cannot denote 10 values together because if 10 here, this is a 2-digit number, no, so we can raise all the bubbles in this column and denote a bubble on tens column. So this would be the notation for 10. Notation for 10. Okay, we cannot indicate in ones maximum number of bubbles we can input over here, that would be 9. Here also we can maximum input totally 9 bubbles because when you put 10 bubbles here, 10 times 10, that would be 100, no, so we cannot denote that one in tens column. 100 means that would be a new column, so in 100 column we can put a bubble to denote 100. So here also we can maximum denote 9 bubbles. 9 bubbles means that will indicate 90. Value 90. Okay, the value we can denote as a higher number in this column, that would be 90. Similarly, here also we cannot denote 10. No. Maximum number we can denote on this ones column, that would be 9. Okay, these are the things we know. Okay, we know all these things already, but in binary numbers, okay, this is an interesting thing. In binary numbers, I'll tell the relationship between binary numbers and decimal numbers. Okay, why we are indicating this one as decimal numbers? You should know that one. No? So, yes, 0 means, okay, ones place means 10 to the power of 0. Okay, 10 to the power of 0. I'll explain why we are indicating 0 here. Okay, that means not only for 10, when you denote any number, for any number when you denote the power as 0, that would be 10. Okay, that would be 10. So this is 10's place value, 10 to the power of 1. Here 10 to the power of 2. Okay, 10 to the power of 2. Similarly, in decimal numbers, we are using 2 to the power of 0. Okay, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 2. In decimal numbers, the base should be always 10. In decimal numbers, base should be always 10. In binary numbers, the base should be always 2. This is the only relationship, okay, only difference between decimal numbers and binary numbers. First thing, we are going to find power of 2.